Hello, this is question 9 from the step 3 paper in 2022. So the first of the mechanics questions. We've got two particles A and B of masses m and km respectively. They lie at rest on a smooth horizontal surface. Coefficient of restitution between the particles is E. E, of course, is between 0 and 1. Particle A is then projected directly towards particle B with speed u. Right, let V1 and V2 be the velocities of the particles after the collision in the direction of the initial velocity of A. Show that V1 is that and V2 is that. Then we move on to something else. Okay, so let's get a little bit of a picture up. So we've got A and we've got B. So A, B, that's mass M, that's mass Km. We start off with U and 0 and we go to V1 and V2. So we're going to set up a couple of equations and then solve them for V1 and V2. So we start off then with conservation of momentum, which is going to give us that mu is mv1 plus kmv2. Cancel a whole load of m's. V1 is u minus kv2. And then we can use our coefficient of restitution. So E is going to be the approach speed, which is u divided by separation, which is V2 minus V1. So that is going to be u divided by, let's get rid of V1. So that will be V2 minus u plus kV2. Okay, and I want to get V2 on its own. So that'll be one thing out of this. What am I going to have? I multiply that across. I've got to then add on an EU to the other side. So I'm going to have a U1 plus E, and then I'm going to divide by a 1 plus K. So that's V2. And what did they give us? So beta times U, 1 plus E, K plus 1. Okay, fair enough. So that's come out okay. And then I've got that V1 is then U minus K lots of that. So KU1 plus E over 1 plus K. So that is going to be U times, well, U over 1 plus K. And then I'll have a 1 plus K and a minus K and a minus EK or KE, whatever way around you want it. So that's going to leave me with, they're going to cancel. So I'll have U1 minus, well, I've put KE. So let's do KE. Okay, so they've come out fine. So that was all good. Next bit of the question then. Particle B strikes a vertical wall, which is perpendicular to its direction of motion, distance D from the point of collision with A, and rebounds. The coefficient of restitution between particle B and the wall is also E. Okay, so show that if A and B collide for a second time at a point D over 2 from the wall, then we get that for K. Right, so we've got a new bit of information then on this. So they're going to be colliding. B's going off to the wall here at distance D, and then they're going to re-collide at D over 2. So A would have travelled a distance, A has travelled a distance of D over 2 at a velocity of V1, and B has travelled, it's going to have two velocities though, isn't it? So it's going to travel D at V2, and then it's going to travel back again D over 2 at a new velocity, which is going to be, so it's got coefficient of restitution E again, so it'll be E times V2 after it's bounced off of the wall. So that means I'm going to have D over 2V1 is going to be equal to D over V2 plus D over 2EV2. Right, so I just need to stick in, I know what V1 and V2 are, so let's just write those out again. So V1 is alpha times U, so that's U1 minus KE over K plus 1, that was V1, and V2 is equal to U times 1 plus E over K plus 1. So obviously I can get rid of all these d's, and then let's multiply by some 2's. So I'll have 1 over v1, so I'll have k plus 1 over u 1 minus k times e is going to be equal to 2 lots of k plus 1 divided by u times 1 plus e, and then I'm going to have a 1 over e times 1 over v2, so I'll have a k plus 1 over eu 1 plus e. So I've got lots of things I can cancel. I can get rid of a u, a k plus 1, and a k plus 1 and a k plus 1. So let's multiply through by everything. I'm going to have an e. What am I trying to get out of this? I'm trying to get k. So, and it's mostly expanded out by the look of it. So, oh, actually, it's not quite. Which bit? Well, they've left this one in the bracket, and the rest of it's going to expand out. So I'm going to have a e plus e squared, and that is going to be equal to a. So I'm going to have a 2. I'm going to have an e. I'm going to have a 1 minus k times e, and then I'm going to have a just a 1 lot of 1 minus ke. So 1 minus k times e. Okay, so I've got e plus e squared is 2e minus 2ke squared plus 1 minus ke. So I can get rid of that and that, which leaves me with a, I've got the minus k's. So I'm going to want to put the k. I've got a k 2e squared plus e is equal to a minus e squared plus e plus 1. So k is going to be, is that what they've got? Yeah, that is what they've got. They've just written it as a 1 plus e minus e squared. So put it in that order, and then factorise the e, 2e plus 1. Okay, so that's dropped out okay as well. So that's the first part of the question done. Moving on to part 2. We've now got 3 particles, A, B and C, of masses m, km and k squared m. Right, so we've got the same ratios going on as we had before. Each one is a multiple of, it's just multiplying up by k as we go up to masses. They lie at rest on a smooth horizontal surface in a straight line B between A and C. The vertical wall is perpendicular to this line and lies on the side of C away from A and B. Right, let's start getting a bit of a sketch then. So we've got that, and we've got the wall, we've got A, we've got B, we've got C. M, km, k squared m. The distance between B and C is equal to D. That's A, that's B, that's C. So that is D. Where was I up to? The distance between C and the wall is equal to 3D. Right, so that is 3D. Coefficient of restitution between each pair of particles and between particle C and the wall is E, where E is that, right? So we can use all the stuff that we came up with in the first part of the question. Particle A is then projected directly towards B with speed u, right? So we even started off the same way. So we're going to start off with u, well, that'll be a 0 and a 0. Then we're going to go V1, V2 and 0, because we know what happens when A hits B. That's exactly the same as what we had at the start. And then we're going to go after B and C collide. We'll have like a V3 and a V4, say. So that's everything that's happening. Show that if all 3 particles collide simultaneously at a point 3/2d, so halfway to the wall again. So again, we're reusing everything that we've done in the previous part of the question. Then we're going to get this. Right, okay, so let's think about movement then. So A is traveling, it's got to do D and then another 1.5d. So it's doing 5/2d. And it's doing all of that at V1. And that has then got to be equal to, what is B doing? B is doing a distance D at V2. So we've got that in there. and then it's going to be doing another 3 over 2d at v3. So we've got those things. Obviously, I can get rid of those d's. I need to know what v3 is. So v3 is the new v1 if u was v2. So, right, so where v3, so it's the new v1. Yes, the new v1, that matches up there. These things are equivalent to each other, but we need that u to be equal to v2. So I need to take what v1 is and then multiply that by v2. Well, except without the u bit in it. Right, so what am I doing? I'm going to have a v1 times a 1 plus e over k plus 1, because that's the v2. But now u is v1. So that is then going to be u times 1 minus k times e over k plus 1, then multiplied by the 1 plus e, and then another k plus 1. So that is what v3 is going to be. So now I just need to whap all of this into one big equation then. Cancel those d's, multiply through by the 2's, seem like a good idea. So I'm going to have 5, and that is going to be divided by v1. So I can forget about all of the u's, so I don't have to worry about that. So v1 goes with alpha. So I'm going to have a 1 minus k times e, and then I'm going to have a k plus 1. Loads of these k plus 1s are going to cancel as well. And that's got to be equal to, then I'll have a 2 over the v2. So that's going to be a k plus 1 again. And then I'm going to have a 1 plus e. And then I've got to have, I've cancelled the u already. So I'm going to have a k plus 1 squared. I've got to have a 3, and the 2 I've gotten rid of. And then at the bottom, I'll have a 1 minus k times e, and I'll have a 1 plus e. Right. So multiply through by various, well, I can get rid of that and that and that. So that certainly helps. Multiply through by everything, and I should have a simpler looking equation. So I'm going to have a 5 times 1 plus e, and that is going to be equal to 2 times 1 minus k times e, and then I'm going to have a 3 times k plus 1. Okay, so 5 plus 5e is 2 minus 2ke plus 3k plus 3. Get rid of that, get rid of that, get rid of that. And I want k to match up with this, because we've just worked out what k is. So I'm getting that k is 5e over 3 minus 2e, which is 1 plus e minus e squared over e times 2e plus 1. Right, so I just need to solve that for e. Right, so I'm going to need to copy this onto a new sheet though, so just give me a moment to pause and copy that across. Not that you have to give me a moment because it was paused. So I'll then, well, just multiply through, get rid of the fractions, and then see what I get. At least they've told us that the solution is going to be a half, so I should be able to factorise what is looking like it's going to be a cubic. So I've got 10e cubed plus 5e squared is equal to 3 minus 2e plus 3e minus 2e squared minus 3e squared plus 2e cubed. Right, so what does that leave me with? I've got 8e cubed, I've got 10e squared, I've got minus e, and I've got minus 3 is 0. And they're saying that I can factorise with a 2e minus 1 on this. So that must give me, let's see if that works, I must have a plus 3 at the end. I must have a 4e squared. So I've got minus 4e squared, and I need to end up on plus 10. So I'm going to need to have a plus 7e there. And that will factorise with 4s and 3s, because that adds up to 7 and multiplies to 12. So I'll have a 2e minus 1, 4e squared plus 4e plus 3e plus 3 is equal to 0. So that's going to be 2e minus 1, 4e plus 3, and then e plus 1 is equal to 0. So I've got that e is equal to a half, or it's going to be equal to minus 3/4, or it's going to be equal to minus 1. So it must be a half because e is between 0 and 1. Right, that was a nicely put together question, really. I mean, it flowed on from part 1 to part 2. There wasn't really a transition between the two of them. Okay, they added in the extra particle, but everything that was in part 1 just came up again in part 2. So, and it's interesting, it didn't have to do anything with particle C, really. I mean, this third mass here that went off and hit the wall and came back was just, largely irrelevant in what the calculations were doing. It was just a case of, well, A hits B, B sets off, hits C, then slows down, and A catches it up. So that was enough information in the second part of the question. Didn't need to do anything else. So yeah, a nice enough mechanics question, but that's always the way, really.